Dear students, how are you all? Today we are going to discuss very interesting problem and easiest problem from operations research. So one of the tool sequencing problem, isn't it? So before we are going to proceed the problem, so you should give like symbol and subscribe this video, share this video to your friends. Okay, let us move the problem. Solve the sequencing problem. So listen man, we are given four machines M1, M2, M3, M4 column wise. Row wise there are jobs, four types of jobs A, B, C, D. And also we are given the respective uh, numbers, datas, isn't it? So I am going to calculate the appropriate order and then total elapsed time, ideal time on M1, ideal time on M2, ideal time on M3, ideal time on M4. So what do you mean by total elapsed time? The machines, there are four machines, totally there are four jobs. So the whole processing time to complete this four jobs in four machines, okay, that is called a total elapsed time. Ideal time on M1 means rest time for the machine 1, rest time for the machine 2, rest time for the machine 3, rest time for the machine 4, isn't it? It means there is no job in the machines. Okay, let's move the solution. This is a four machine problem. Let us convert four machine into two machines. So the condition is given by Johnson's, isn't it? So that it is called the Johnson's condition. There are two conditions. Number one, minimum of M1 which is greater than or equal to maximum of M3, M2, M3, M4. Similarly, the second, minimum of M4 which is greater than or equal to maximum of M1, M2, M3. I'm going to take minimum from M1, that is 8. Maximum of all the three M2, M3, M4, that is 19. Condition number 2, minimum of M4, that is 14. Maximum of M1, M2, M3, that is 13. So any one of the condition must be satisfied for to convert four machine into two machines. Condition number 2 satisfies the condition, so that I'm going to convert the four machine into two machines, isn't it? Okay. Now new machines are called G and H. What do you mean by G? The combination of first three machines M1, M2, M3. And what about H? The last three M2 plus M3 plus M4. I am making a new machines called G and H from M1, M2, M3, M4, isn't it? So 28, 29, 26, 33, 24, 30, 19 and 26. Okay. So among the two machines G and H, I'm going to select the least value. Where is it? 19 is the least value which lies on G, the first machine, and the job is D. So if the machine least value lies on G, I'm going to proceed from left to right. Okay, if the least value lies on H, I'm going to proceed right to left, isn't it? That is the direction I have given here. Sequence order. So the least value 19 which is lies on G, the respective D. So that I'm going to fill the leftmost cell. Okay, now I have completed the first job, that is D. Among A, B, C, again once again I am going to select the least value, that is 24 lies on the same machine G. So I'm going to allocate the next cell of D, that is C. Okay, there are two cells unavailable. I mean, there is no allocations. So A, B, I'm going to select the least value. 26 is the least value. It is also lies on the same machine G. So after C, I'm going to allocate B. The last one obviously goes to A, isn't it? So this is the way you have to find out the sequence order. Okay. Then I move to next one. This is the very important table. So from that I can calculate the TET, ideal time for each machines. Okay, so first I have to fill it in the column wise M1, M2, M3, M4, row wise D, C, B. This is the sequence order. Already we have found, isn't it? Okay, all the machines I have to split additional two columns, sub columns called in, out, in, out, in, out, in, out, isn't it? Okay, let us start the procedure. Start with the machine D, isn't it? So for D, put 0, initial work start 0. Okay, so for the D job, for M1 we are given, see here, see this is for D, we are given first machine, that is, okay, 8 is given. So 0 plus 8, 8. Then move to the next machine M2. So 8 is the ending time of M1, at the same time it is the entering time of M2, isn't it? Okay, what about machine 2? So machine 2 we are given, that is, see this machine 2, the same D, that is 5. So 8 plus 5, that is 13. It is a ending time of machine 2. It is the same, I mean entering time of M3, that is 13. Okay, go to D. In M3 we are given 6 is given, isn't it? So 13 plus 6, that is 19. It is the ending time of M3. At the same time, it is a starting time of last machine M4. Okay, D. What is the last one? That is 15 is given. So 19 plus 15 is 34, isn't it? So in this model, we have to find out the first job in all machines. Okay, we have completed the first job. For what does it mean? The first job completion in all machines 34 hours, isn't it? Okay, now let we move to let us move to the next job, that is C. From the first one, M1, see M1 only, so forget about M2, M3, M4, consider only M1. Okay, for D, 8 is the outing time, I mean finishing time, so it goes to the next job C, it is the entering time. And for C, in machine 1 we are given, see this, question 1 we are given, for C 9 is given. So 8 plus 9, it is 17. It is a finishing time for C. So 17 goes to the next job B, it is entering time. For B we are given question 1 12. 12 is given. So 17 plus 12, it is 29. It is the entering finishing time of B. So the same time goes to the next job, that is final job A, that is 29. It is the starting time of A. So what is given here for A, machine 1, 13 is given. So 29 plus 13, it is 42. What do you mean by 42? Can you define about 42? 42 hours taking machine 1 to complete all the jobs, isn't it? Okay, now I'm going to start the next machine. So already we have completed the first one, 8 and 13. Now I'm going to proceed the next C, B and A in machine 2. Okay, before I'm going to proceed, see, this is a very important thing. Here the D, the very first job D, which is completed by 13 hours in machine 2. Already we have found out. And also in machine 1, C, see the next job C, 17. Okay, so up to 17 hours, it cannot be proceed. I mean, M2 cannot be proceed. Okay, suppose 17 is there, so you must select the largest value of both 13 and 17, isn't it? So please fix these places. So before we are going to start this place, you must clear on, you must focus on this place and this place, which is the largest value. So just apply here, so that is applicable. So 17 is the largest value. So 17 plus the next value, which is we are given in C machine 2, we are given 7. Okay, so 17 plus 7, 24. Similarly, we are going to proceed the next one. Here 24, here 29. This is the largest one, 29. So give it 29 for B, and then the value is given for M2, that is 6. So 29 plus 6, 35. Next one, here 35, here 42. So we are going to allocate the maximum value, that is 42, isn't it? So I 42, and then we are given here the last job A, that is machine 2, that is A is what is given, machine 2, 8 is given. See, this is 8. 8 is given. So 42 plus 8, 50. What do you mean by this 50? So in machine 2, the total jobs A, B, C, D have taken to finish that particular work at 50 hertz, isn't it? Okay, now move to the next one, that is M3. So already we have found this 19. So before proceed, kindly check this place and this place. The next job of C, that is C, M2 C. So 24 is 19. Apply the largest value, that is 24. Okay, now 24 plus what is given here, M3 for C, that is 8. So 24 plus 8, 32. Then check it. Okay, this is 32, this is 35. Which is the largest value? 35. Allocate here. Then what we are given in the problem itself. For B, 8 is given, so 43. So before we are going to start, check 43 here, 50. 50 the largest value. Allocate for A in machine 3. Okay, what is given here? That is third machine A. 7 is given, so 57. So what does it mean? The machine 3 complete all the jobs at 57 hours, isn't it? Okay, go to the last column. So here already we have found 34 and 32, which is the largest one, 34. So 34 allocate. Then C, the last machine 15 is given, so 34 plus 15, 49. 49, 43. 49 is the largest value, that should be allocated for B. So for B, 19 is given. So 14 plus 19, it is 68. 68, 57. 68 is the largest value, allocate here. Then last one for machine 4, 14 is given. So 68 plus 14, 82 hours, isn't it? So now I'm going to, this is a very important number. Okay, this is called a total elapsed time, the whole process. Okay, now the total elapsed time 82 hours. So total elapsed time which is available always in this place. Okay, the last one, the corner place. Okay, please remember. Then idle time on machine 1, how to calculate? So go back to the table. This is 82 minus 42. This is the time. So 82 minus 42, 40 hours is the resting time of machine 1. Similarly, idle time on M2. So M2, see, first one at 8 hours. Okay, 8 hours it is at rest. Okay, so that add 8, first put 8, then total elapsed time minus time taken by machine 2, plus you have to check this one. Okay, 17, 13, the difference is 4. 29, 24, the difference is 5. 42, 35, the difference is 7. So you must add all the things, you will get 56 hours. Okay, time to, I mean machine to take at rest. Okay, similarly go to the next one, M3. So how to calculate ideal time? 13, this first 13 hours, M3 is at its position, isn't it? So include this 13 and then find the difference, 24 minus 19, so it is 5. And then 35 minus 32, 3. 50 minus 43, 7. Then 82 minus this 57. So the answer is, I have written here. So the answer is 53 hours, M3 at rest position. Go to the last one. So see the table. So this is a table. This 19 hours, M4 at resting position, isn't it? Then you have to check this place. So same numbers, there is no difference. So 19 hours, M4 is at its position, isn't it? Thank you, my dear friends.